Planet orbiting backwards, rewriting astronomy. Astronomers uncover a planet with a backward orbit, a revelation that could transform our understanding of astronomy. In a remarkable turn of events, astronomers have unveiled a discovery that challenges the traditional views on how planets form within binary star systems. They have confirmed the existence of a planet in the new Octantis system that orbits in a retrograde direction, essentially moving in the opposite direction to its binary stars. This groundbreaking finding, which was published in the journal Nature on May 21, 2025, not only questions established theories, but also paves the way for new explorations into planetary systems nestled within tightly bound binary star environments. The research, spearheaded by Professor Man Hoi Lee and his dedicated team from the University of Hong Kong, provides insights into the potential formation mechanisms of such a unique planet. A pivotal aspect of this discovery was the precise radial velocity data collected using the HARPS spectrograph at the European Southern Observatory, which played a crucial role in confirming the planet's unusual orbital path. The new Octantis system, estimated to be around 2.9 billion years old, consists of two stars: New Oct A, a subgiant star with a mass approximately 1.6 times that of our Sun, and New Oct B, which has about half the mass of the Sun. These stars complete an orbit around each other every 1,050 days. Although signs of a planet in the system were first detected back in 2004, it was only through recent high-precision observations that the research team could definitively confirm the planet's presence and its peculiar retrograde orbit. The unusual characteristics of retrograde orbits in binary systems. In the majority of planetary systems, planets typically orbit in the same direction as their host stars. This alignment is generally a result of the way these systems develop, with the surrounding material coalescing in a uniform direction. However, the retrograde orbit of the new Octantis planet, moving counter to the star's motion, poses a significant anomaly that has left scientists scratching their heads for years. Such retrograde planets are exceedingly rare and are theoretically challenging to form or sustain, especially in binary star systems where the gravitational forces from both stars can complicate stable planetary orbits. To validate the retrograde nature of this orbit, the research team conducted an extensive analysis of both historical and newly acquired radial velocity data, which measures a star's motion toward or away from Earth. These observations, gathered over an impressive span of 18 years, confirmed that not only is the planet's orbit retrograde, but it's also nearly aligned with the orbital plane of the binary stars. This significant finding was further corroborated by additional high-precision data collected using the HARPS spectrograph. The team's research contributes to a growing body of evidence, suggesting that retrograde planets may be more prevalent than previously believed, particularly in systems with evolved stellar components, such as white dwarfs. In fact, this study raises intriguing possibilities that planets like the one in New Octantis could provide new insights into the formation and evolution of planetary systems across various cosmic settings. Exploring the history of New Octantis, a white dwarf, and its unique planet. To fully grasp the existence of this unusual planet, it is crucial to understand the history of the New Octantis system. The secondary star, New Oct B, has undergone significant evolutionary changes over billions of years. Initially, it had a mass approximately 2.4 times that of the Sun, but it eventually transformed into a white dwarf after depleting its nuclear fuel. Consequently, New Oct B now possesses only about 25% of its original mass. The research team posits that the transition of New Oct B into a white dwarf likely influenced the surrounding material, which could have played a role in the planet's formation. One hypothesis suggests that the planet may have originated from a retrograde disk of material expelled from New Oct B during its transition to a white dwarf. Alternatively, it is possible that the planet was captured from a prograde orbit into its current retrograde path around New Oct A. To clarify the origins of the system, the team analyzed the initial configurations of the stars and their evolutionary trajectories over time. Their findings indicated that the planet could not have formed around New Oct A concurrently with the stars. The evolution of New Oct B and its transformation into a white dwarf were pivotal in shaping the current state of the system. Ho-Wan Cheng, the lead author of the study, elaborated. We discovered that the system is approximately 2.9 billion years old, and that New Oct B was initially about 2.4 times the mass of the Sun, evolving into a white dwarf around 2 billion years ago. Our analysis indicated that the planet could not have formed around New Oct A at the same time as the stars. A fresh perspective on second-generation planets. This research introduces the captivating notion that the new Octantis planet may be classified as a second-generation planet. Dr. Trifon Trifonov, a co-author of the study, proposes that the planet could have either been captured from a prograde orbit around the binary system or formed from material expelled by New Oct B. He stated, "We might be witnessing the first compelling case of a second-generation planet, either captured or formed from material expelled by New Oct B, which lost more than 75% of its primordial mass to become a white dwarf." This revelation opens new pathways for investigating the evolution of planets, particularly those that have formed under unusual circumstances or have been captured from different orbits. The identification of retrograde planets challenges the conventional models of planetary